Swayam Prabha. Digital India. Educated India.
Good morning, gentlemen. Let's continue our discussion on the development of approximation for a triangular element. So we are looking at, so in the last lecture, this is a continuation of the same thing of the board. So we started off with this one, the phi in terms of a plus bx plus cy. So this is linear terms in xy, so that the derivative exists. So that's the minimum thing. And if we need, we can take more terms, but at this moment we take only the expression in terms of 3 coefficients, because we would like to express this one. We would like to express this a plus bx plus cy in terms of looking at this one in terms of phi I and phi j and phi k. So that is our goal, rewriting this ABC in terms of phi I, phi j, phi k. So we went through this procedure. So the same thing now is phi I is this expression at xi, yi, and so on. So then we formulated this equation in terms of coordinates, and then on this side we have the nodal values of the function. On this side here we have the coefficients ABC of the expression. And I wrote this coefficient matrix as C. Please don't get confused with this C. So C multiplied by ABC. And now the ABC was rewritten in terms of phi A, phi j, phi k by taking the inverse of C. Okay. And then coming back to this one. So the mathematical way of expressing is that the approximation is y1xy ABC times this one. And C inverse we need to calculate, and that you multiply. So this is a 1 by 3 matrix and this is a 3 by 3. If you multiply 1 by 3 and 3 by 3, you get still again a 1 by 3, which is written as Ni, Nj, Nk. Incidentally, these Nj, Ni, Nj, Nk are functions of xy, and multiplying phi I, phi j, phi k. So in the long hand, so again like this one. So now we have been successful in writing this approximation function in the element in terms of phi I, phi j, phi k, which are the nodal values. And then this nixy, njxy, nkxy. So these are functions in terms of the element coordinates, okay, elements, and then some other expressions xy. So this mathematically, this seems to be straightforward, but a little involved, though not coding wise. But let's look at an alternate way of. So these are called the Ni, Nj, Nk are called the shape functions, maybe trial functions, associated with the nodes I, j, and k. I will just explain you what we mean by the shape functions and what are their characteristics. So alternatively, alternately, so what we have here, we straight away start with the expression here, right? So we start with phi we start with this one and try to get Na and j and k. Okay, so the thing here is that this is the approximation function expressed in terms of xy. So interestingly, what we do is that this expression phi e evaluated at xi yi is nothing but phi I, and this is nothing but this ni, which is a function of xy to start with, but substitute xi yi, and nj evaluated at xi yi, nk So if you look at this equation, so this is phi I is equal to this one. We can further write it, take this phi I on to this side, and then let's keep it 0 on the left side. So what we have here look at this one. So I'm writing everything on the right side. Okay, so this is the equation which need to be satisfied by Ni, Nj, Nk together with phi I, phi j, phi k. So if this has to be valid for all values of true for all phi I, phi j, phi k, then what need to be done here is that each of these things in the bracket minus 1 is 0 and nj xi yi is 0 and nk xi. So this is for evaluating at xi yi. Right? This is evaluating. So we took the original expression and then we put xi yi and we ended up with this equation. So using xj, yj, what does that mean? So at phi I at xj yj should be equal to phi j, and then all these things will become xj yj, and xj yj. So what will happen is that, so it will say then ni at xj yj is equal to 0 and nj at xj yj is 1 and nk at xj yj is 0. I hope you have followed it. So the same thing at xj yj should be phi j here, and it should be xj yj here, xj yj here, xj yj here, and then doing the same simplification. So this is what you get. And using xk yk, we get this evaluated at xk yk should be equal to phi k, and then it will become ni xk yk is 0, nj at xk yk is 0, and nk. Okay, so these are the values of ni, nj, nk at the three vertices. Okay, so if that is the case, so what we have seen here, going back, So what we can say that is a plus bx plus cy is written in terms of if a plus written as ni phi I if this is written in this manner. So on this side you have a linear function, and then these are functions ni and j and k functions, and phi I, phi j, phi k are constants. So what do you think of this ni? Ni is a function xy, right? So what kind of function will it be? So if this is linear function in three terms, 1xy, so ni also has to be a similar function, and at this moment you can write it as so this is let ni be this. So we will try to find out what are these ai, bi, ci are. Okay, so there are three coefficients here, and then if you look at the conditions on ni here, so if you look at the first row, what it says is that ni at xi, yi. So what we have here is 1, ni at xj, yj is 0, and ni at xk, yk is 0, right? So using these three conditions now on ni, so we can write it same thing here, and this can be further simplified. Using this, what do we get here? We can apply this here. So that means that so we have ai plus bi xi plus ci yi is 1, and ai plus bi xj ci yj is 0, and the third one is ai bi xk plus ci, right? So these are the three equations. So we can concisely put them as 1 xi yi, 1 xj yj, so we are writing it in the matrix form 1 0 0. So these equations I just put it in the matrix form. So if you want to write ai, bi, ci, so in fact if you want to write ai, so you can use the Cramer's rule. So that means that you can write ai, if you put it here, so it is nothing but, this is very easy to xkyj divided by determinant, and bi you put 1 0 0 here, so you have yj minus yk by determinant, and so similarly here we have xk minus j, where determinant is the determinant of this matrix. So what is this determinant of this matrix? Is nothing but, if you recall your, so this determinant here of this 1 xi j determinant of this matrix, if you recall, So this is nothing but twice the area of the triangle. Okay. So if you have some means of finding out the area of the triangle, you can directly do that. And essentially you have now xj, yk twice the area. A repetition here. Okay, so this is how it is. And then what is these things? AI, BI, CI are nothing but values in terms of the coordinates xi, yi. And so that means that here, that means that this shape function nixy is given by this one. Okay. So similarly, you can continue to write this one. So njxy. So similarly, you can do the other shape functions njxy. So where? So aj is just a cyclic thing. So xk, yi, yk, xi, and bj will be yk minus yi, and cj is xi minus. Just for the sake of continuity, I'm just writing out all these terms. And the function nkxy, so similarly can be written as okay, where ak is xi, yj, and yi, xj, and bk is yi minus yj, xj minus xi. Okay, so this is this. By this way, we are able to find out all the shape functions ni, nj, and k. So once the triangular coordinates are given, so we can definitely evaluate all these ai, bi, ci. And interestingly, it's also important to know the functions, the shape functions, how they look like. So this is very important. Let's just let's draw this. So interestingly here, this ni, if I want to draw it in a nice isometric view, so how it looks like here is that this ni that's given by this expression, interestingly, it has obviously it has a value of 1 at node 1 and goes to 0 linearly. Right? So that was the expressions. For example, ni at xi, yi is 1, ni at xj, yj is 0, Ni at xk, yk is 0. So this is, if you just so this looks like a tent with a pole here is a value of 1 here, and then it linearly goes to 0 at the other two nodes. So this, well, this can be continued. So if this is how, if you want to write nj, if you want to write nj, so it's very easy. Nj is 1 here at this, and it goes to 0 at the other two nodes. So the same thing can be said about the nk, which will be having a value of 1 here and goes to 0 at the other two nodes. Okay, so this is a very systematic procedure. The same procedure will be followed for deriving approximate functions for any other element. Okay, this is three-noded triangle. There can be many other elements like rectangle, like quadrilateral, like higher order elements. So the procedure is all same. So what is that which we observe here? Shape function will have the expression ai plus bix plus ciy and maybe more terms. But the important thing here is that the shape function will have a value of 1 corresponding to that node and 0 at other nodes, right? So ni has a value of 1 because it corresponds to ni phi I, and it becomes 0 here and 0 here. So this is a very simple thing to remember to derive any shape function. So these shape functions are systematically done in this manner. So now let's move on. Let's derive the finite element equations. So remember, so the basic thing is that the phi of the element is ni is a function of xy, phi I, so this is the basic thing. Okay, so what we have here, so to derive the finite element equations, so let's go back to the weighted residual statement, so which says that this dou wi by dou x k dou phi hat by dou x so we can even, going back to this equation, let's write it. The equation, this is on the left side. So we'll take this wiq so this is the equation, the weighted residual statement, of course the weak form, and we just wrote it that q we take it to the right and q bar also we took it to the right, and this is an integral on q comma q. So now if we put the expression, so this is for overall thing, and then if you want to calculate it for the omega E, and wherein we use the expression phi hat to be phi hat of the element. So here we use the element here. So let's just look at this expression. Rest of the things we'll calculate it later. So this is the one which on the element E. In fact, the total summation omega is a summation of all the elements. And what we say is that we calculate it for one element and then apply the assembly procedure. Okay. So here, let us just do this. Let's assume that the weighting function, substitute weighting function, use the weighting function as Ni. Okay. So we use the same, obviously we use the same trial functions as that of expression for phi hat. So if that is the case, so now let's further simplify it. So we use dou Ni by dou x, k, and this phi hat we write it as dou x of as Ni phi I. This is for element. So this is this, and then we also have the other term with the derivative with y. Okay, so let's continue the simplification. I think we can now very well best. What is Ni? Ni is, don't forget, Ni is Aii plus Bix plus Ciy. So this derivative with x now can be written as what? Bi, right? And then this k is there. And what happens to here? This is the derivative with Ni, with x of Ni, Nj and Nk. So if that is the case, so then we'll write this one as Bi, Bi phi I, Bj phi j, and Bk phi k. Right? So this is that expression. And now it is, sorry, here there is Ni here. Dou Ni by dou y is nothing but Ci and k here. And the same thing here, similarly. So it is Ci phi I, Cj phi j, and Ck phi k x dy, right? So we have taken the derivatives. The derivatives are very simple. They become constant here. And then this becomes, if you look at this integral here, so all these terms are constants as far as the element is concerned, and the area here dx dy will become area of the element, that's all, and the rest of it is all constants. Okay, so we will have here bi square I bi bj ij bi bk k, right? In fact, we can even combine it. Let's combine it because there's a phi I is occurring here. So it is k will take it out. So it's bi square plus ci square phi I, and here bi bj plus ci cj phi j, and let us bi bk ci bk and multiplied with area. And like this we will have this is the first equation, right? And the second equation we have to use wi is equal to, using second equation, we use wi is equal to nj. Then we follow the same procedure. In fact, many of the terms are very similar. Then the second equation will be ki. Okay, so bj bi cj ci I bj square plus cj square ij and bj bk cj ck by k. Okay, so similarly third equation, just 1 minute. So third equation, the weighting function will take nk, and that will be same thing here. So it will be k bi ck ci by I bk bj ck cj by j bk square plus by k. Okay, so these are the third equation, and all right, so we will continue this one in our next lecture. So this has to be simplified and reevaluated. There are other integrals also which we need to evaluate on the right side. Okay, so we'll stop it at this point for the moment. We'll continue this in our next class. Bye then.